So my name is Travis Brown. My Twitter handle is up here. It's @TravisBrown. So if there are questions that you have that we don't get to in the talk, please just ping me or catch me afterwards, and we can talk about those. I haven't posted the slides online yet, but I will be posting them online soon. So if you are following me, you'll be the first to get that news. Okay, so a little bit about, I want to introduce myself first. So I've been working professionally in Scala for about 5 years. I've been active in projects like Shapeless and Scala Z. So does anybody here use Shapeless? Okay, so a few people. What about Scala Z? A few more people. Okay, so Shapeless is a library for generic programming in Scala, and Scala Z is a library for category theoretic abstractions. I spend way too much time on Stack Overflow, so as of this morning, I think that number is actually 892 questions in the Scala tag, or answers in the Scala tag on Stack Overflow. And I joined the open source team at Twitter last May as an open source advocate. So what that role means is that I represent external adopters of our open source projects, and I work with our internal engineering teams on projects like Finagle specifically. So, so Finagle is our RPC system that we use for almost all services at Twitter now. I also teach Twitter University courses. So Twitter University is our internal training program that we offer a wide number of courses in technical topics for engineers at Twitter. I also help to organize events. So if you are using Finagle or if you're interested in Finagle, I'd encourage you to check out this event, FinagleCon, that we'll be hosting next in August. So this is August 13th. So if you're in the Bay Area, we'd love to have you attend. This will be part of Scala by the Bay. Okay, so I wanted to go into a little detail first about the focus of the talk. So I'll give an overview of the history of Scala at Twitter, but I don't want to spend a lot of time talking about that because there are a number of other presentations that do a good job of covering this by people who have been at Twitter longer than I have. Also, this won't primarily be a talk about scaling Scala in terms of runtime performance. So this will be an issue that's related to a lot of the things that I will be discussing, but it won't be the focus of the talk. Okay, so what I am going to talk about is how we have developed a culture of Scala at Twitter, and what that means, and how we pick the parts of Scala that we value and that we want to promote across our code base, and the parts that we try to avoid. I also will discuss our relationship to the larger Scala ecosystem, other open source projects outside of Twitter. Okay, so since most people here are familiar with Scala or are using it now, I just want to give a quick introduction for the people who aren't. So what Scala is probably best known for is the fact that it's an attempt to combine two very different programming paradigms. So on the one hand, it contains a lot of elements of object-oriented programming that it inherits from Java, and on the other hand, it includes a lot of facilities for functional programming. So in the first code example up here, you'll see a very simple class hierarchy that the syntax is different from Java, but it will look, you could translate it very directly into Java. The ideas are the same. In the second example, here, this is using a number of the different pieces of facilities for functional programming. So what I've done is I've built an infinite stream starting at 1 of integers, and I filtered out all of the even integers and then mapped an anonymous function that squares each one of those integers over that infinite stream. Does anybody know, so this is just a quick footnote. I wrote this code last week, and then this morning I decided, well, I might as well make sure that my code examples actually run. If you paste this into a Scala REPL, it will actually just sit there. So this is I wish that this was a joke, but it's not. There's a regression introduced in Scala 2.11 in the filter not on stream that means that it's no longer sufficiently lazy. So I'll leave that there as a cautionary tale. Okay, so this slide is meant to be kind of intimidating. So this is a selection of the array of language features that Scala provides. And almost every organization or person who's using Scala tends to pick which of these language features they value and which of these features they want in their code base and which they want to avoid. And those decisions tend to fall along a kind of spectrum, where on the one end of the spectrum you have people who want to treat Scala effectively like a better Java. So these people, what they want is a lot of the concision that you get with Scala when you are building using it in an object-oriented way. And a lot of the nice defaults, so things like case classes, where you don't have to do a lot of the kind of boilerplate implementation of equals and hash code and things like that. Then on the other end of the spectrum, you have people who really want to treat Scala as a pure functional language. And so these teams like this tend to avoid a lot of the issues, a lot of the kinds of things like subtyping that causes problems for Scala's type inference. And this is an implementation of the power set function. So it takes a list of elements and it returns a list of all of the subsets of that list. And this is just an example of the kind of thing that you can do with the abstractions in Scala Z. So it's very clever, and it's beautiful and elegant, but it's also just completely unintelligible to somebody who doesn't have time to really dig into what's happening there. Okay, so next I'm going to talk about how Twitter got started with Scala. So this is a slide from a presentation that was given by Alex Payne, who was an engineer at Scala or at Twitter in the early days. And this presentation was, I think, from April 2010. So this is within the first few months of when Twitter started developing Scala projects. And it's a pretty good overview of what we see as the benefits of Scala today. And the kind of underlying reason for Twitter's need to look at languages like Scala was that Twitter was getting to the limits of its ability to efficiently scale the monorail. So the monorail is the kind of internal name for the Ruby on Rails application that drove Twitter before the move to Scala. So if you were using Twitter before 2009, 2010, this image is probably familiar to you. Okay, so this is a quick overview of the history of Scala at Twitter. So in the very end of 2009 and the beginning of 2010, teams started building specific components in Scala and replacing pieces of the monorail with those components. So in August of 2010, Marius Eriksson and others at Twitter introduced these two types, future and try, which are they're the foundation of a lot of Scala usage at Twitter, and they're the core of the Finagle application. Okay, then in May of 2011, work began on Scalding, which is our application for building MapReduce jobs for Hadoop in Scala. And then, let's see. So December of 2011, we started using Scala Test, which we're still using Scala Test. It's something that works very, very well for us. Also in 2011, we published the first version of the Scala School, which is it's now an open source resource that is widely used in the Scala community. And it formed a lot of the kind of the principles of our use of Scala at Twitter initially.
Except the style guide.
So the style guide is actually effective Scala. So Scala School is a set of notes from lectures that were given at Twitter in the very early days of Scala at Twitter. Yeah. So Effective Scala is the style guide. This was published in February of 2012. And it's very, very widely cited still, both inside of Twitter and in the Scala community. Okay, so when we started on Scala, we were using Scala 2.7, and then by May of 2012, we were on Scala 2.9. In 2012, and then over the course of 2013, Twitter was starting to see the benefits of moving parts of the monorail to Scala, and so there was a lot of interest in accelerating that process of getting off of the monorail and onto Finagle. And I'll talk in a little bit about how what the elements of that effort looked like. 2012, we started using Scala Check, which is a library for property-based testing that works very well with Scala Test, and we're using widely at Twitter today. And then last September, we completed the migration to Scala 2.10, and we're just this summer wrapping up the migration to Scala 2.11. Also, so this is a kind of unofficial account for the monorail at Twitter, and last month, this is its kind of silly announcement that web traffic is no longer being served from the monorail. Okay, so if you're interested in more of this kind of context about why Twitter uses Scala and how that happened over this period between 2010 and now, I'd encourage you to look at these presentations. So the first 3 video is available for, and the last one, there's a really good set of slides from Marius. Okay, so this is a snapshot of what Twitter's Scala code base looks like today. So we have several million lines of Scala code, and it's about a third of the entire Twitter code base, and it's organized in a monorepo. And as of Monday, we merged what was essentially a duo repo, so two large sets of projects into a single project. Where now all of our code lives in a single repository, and the dependency or the relationships between projects in that repository are source dependencies.
Sorry.
Yes.
So what's the other? It's not 35%. Still Rail.
There's a very large amount of Java in there too, not as much as Scala, and then other miscellaneous things, C++, Python, other languages. Okay, most of our core libraries in Scala are available at this point as open source projects. So we have about 40 Scala projects on GitHub. And a few of these projects like Algebird and Scalding actually primarily live on GitHub. So they don't also live in the monorepo. They're developed out in the open entirely, and they're published to public repositories and then consumed as third-party dependencies inside of Twitter. But that's still kind of the exception. So most of our Scala projects they live primarily in the monorepo, and then they're synced out to GitHub, and commits on GitHub are pulled in to the monorepo. And for those projects that live in the monorepo, everything in the monorepo is built with Pants, which is our build tool for the monorepo that we've developed over the past few years together with Foursquare and some other companies. And then we maintain 2 build configurations for all of these open source projects. So internally, they're built with Pants, and then the open source projects are built with SBT, which is probably right now the most popular build tool in the Scala community. Okay, so I mentioned that we're using Scala Test and Scala Check. We also have recently started using Scala Style for certain projects in the monorepo. And we're really happy with these dependencies and the ways that they help us maintain our code base. But we don't have many runtime Scala dependencies. And I'll talk a little bit about why that's the case in a minute. We're also still using our own implementations of Future and Try. So I mentioned that in 2012, these were first introduced, 2011 or 2010, These were first introduced into the Scala code base at Twitter. And then in Scala 2.10, a year later, these types were also introduced into the standard library. But for reasons that I'll discuss more in a few minutes, we're still on our own versions of this. OK. So that's where we are with Scala today. And I want to talk about some of the challenges that we've run into in getting to that point. So the first of these is just Scala is a really big, complex language. And you do have to be really careful that you don't have a kind of splintering of your code base where every individual team is just picking a set of features that other teams won't find compatible with their approaches. And also, there are a lot of really powerful abstractions in Scala, but these often come with a cost, not just in terms of intelligibility, but also in terms of runtime performance. So it's very easy to write idiomatic Scala that will have an allocation profile that's completely unacceptable for certain applications. OK. So another challenge is that the Scala, both the language and the ecosystem, are still evolving fairly rapidly. So I joined Twitter last May, and over the first few months that I was there, I got to witness this migration from Scala 2.9 internally to Scala 2.10. And there were a lot of things that were introduced in Scala 2.10, a lot of things that were deprecated, and a lot of changes to behaviors that had a big impact on our code base. So the biggest issue there was just getting all the tooling up to speed, but there are changes happening to the language that make it difficult to migrate quickly. So 2.9, I think it was about, 2.9 was introduced in January of 2013, I believe. Or no, I'm sorry, 2.10. And we moved entirely to 2.10 19 months later. And our actual process of making that move was just the last few of those months. OK. Also, so we hire a lot of developers who don't have a background in Scala. And we also have many teams at Twitter that don't work primarily in Scala. So our core libraries are written in Scala, and they're using Scala libraries, but they're doing that from Java. I also want to focus specifically on one kind of challenge of a Scala code base in the context of a monorepo that might not be immediately evident. So one of the big advantages of a monorepo is that it facilitates sweeping refactors. So even if you're working on a library that is very like at the root of the dependency graph for your code base, it's possible to make a breaking API change and then very easily find all of the places in the code base that depend on that change and that would be broken by that change. And so often the way this will work is you'll find the teams that are your customers whose code you've broken, and you'll work with them to fix that code. And then you will make a single commit that both changes the API and changes the API everywhere in the code base. So this makes refactoring much less expensive than it is in a context where teams see each other's code bases as black boxes. But it also, for a language like Scala specifically, it means that because there is an expectation that teams don't treat each other's code bases as black boxes, that code across teams needs to be intelligible to everyone. So this is just a quick example of the kind of diversity of syntax that Scala offers. So all 5 of these definitions here, they compile to exactly the same bytecode, but they just look radically different. And so if you're new to Scala and your team has been working in a certain kind of context and you're using one of these styles, and you go out to another team that's using a different style, this has both an immediate kind of there's a cognitive burden. It's going to be difficult for you to read, and it's going to feel unfamiliar. You're going to be less confident in your refactoring, and there's space for conflict between teams over things that aren't really very relevant. So Syntactic inconsistency and the kind of really wide range of syntactic sugar and syntactic possibilities that Scala offers, that's one challenge that you need to address when you're working in this context. But also the kind of, we looked at the beginning at that huge list of Scala language features, and the choices that teams make about those language features and those abstractions can be just as difficult in this kind of context. Okay, so one answer to this problem that I would consider the wrong answer, and that a lot of people at Twitter would consider the wrong answer, is to just say, okay, we're going to treat Scala like a better Java. We're just going to throw out all of the advanced abstractions, all of the pieces of functional programming, and use a core set of language features that people from a wide range of backgrounds will be comfortable with. So instead, what Twitter has done, so if we're thinking about the spectrum from Scala as a better Java to Scala as a pure functional language, Twitter's tried to find a place between those two that is both comfortable for people from a wide range of backgrounds, but also gives us some of the advantages that functional programming in Scala provides. So there's a strong preference for mutability, which is something that, in general, it's encouraged in Scala, and that we've tried to push as that you fall down to mutable data structures and mutable operations only when it's necessary for performance. There are other things. So this is we in general aim to model errors represent errors as values. So the only exceptions that will be thrown are fatal exceptions that we can't deal with at the value level. That's another idea from functional programming that is very important in our code base. And then lastly, this core abstraction, the future, and the idea that anytime we have two computers talking to each other, we represent that conversation as a function from a value to another value in a future. That's a core abstraction that we're committed to in the Twitter code base. So we want to build a culture around this set of principles. And so some of the ways that we've done that from the very early days is through documents like Scala School and like Effective Scala. And then also, more recently, we've been working on a Scala guide that is a kind of successor to Effective Scala that's currently internal only, but we'll be pushing parts of that work out into Effective Scala over the next few months. We also have an internal tech radar, which is it's maintained by this Twitter architecture group that gives recommendations about both techniques and then also third-party libraries and internal libraries as well. From the beginning, we've also, code review is an important place to kind of try to instill this culture across teams at Twitter. And more recently, we've started using an internal Q&A system. We use chat rooms. We use these tools like Scala Style. And a few of our projects use Scalariform, which actually does rewriting instead of just flagging issues. But lastly, I want to emphasize this element of internal training. So I mentioned earlier that in late 2012, early 2013, Twitter was really trying to accelerate the move to Scala, and part of that effort was developing an internal training program for engineers. And so the creation of Twitter University in 2013 was a really important part of that effort. And we now offer dozens of Scala courses. So Scala Essentials is a 12-hour course that's a part of onboarding for a lot of engineers at Twitter. And then also, I've been working on developing materials for a new series of advanced Scala courses. And a lot of these materials will be open sourced over the next quarter or two. Okay, One specific issue that I just want to mention quickly that's a little bit unusual about our use case is because our core libraries are built in Scala, but we have a lot of teams that are working primarily in Java, we care a lot about both sides of the Scala-Java interoperability story. So if you've worked with Scala and Java together, you probably know that while the using Java from Scala is very, very clean, and it works almost perfectly, the opposite direction is much more complicated. And if you've done this, you've probably seen a lot of dollar signs in your Java code that you have to fall down to the level of name mangling to actually use Scala projects in Java efficiently, unless you have specifically designed your Scala code in such a way that it's easily consumable from Java. So this is something we've been pushing for over the past few months, is to put together a set of conventions and recommendations for the core Scala libraries so that they can be used from Java without a lot of these workarounds. Okay, so there's still a lot of sharp edges. So even with a good training program and good code review and good documentations and style guides, there's still a lot of areas where we run into issues. And again, because Scala is a very, very complex language, people are going to get burned, and there will always be problems. But the kind of core strategy of using these different tools, like a good set of documents, an internal training program, and good tooling, it's on the whole has worked pretty well for us. Okay, so next I want to talk about the other side of the story, which is the use of Twitter's relation to the larger Scala ecosystem. And these are a few of the flagship Twitter open source Scala projects. So we've got Finagle, we've got Finatra, I mentioned Scalding earlier, and then Summingbird is in the top corner. It's a newer library for streaming MapReduce on Hadoop that works with Scalding. And then Zipkin is a distributed tracing library that we have. So we have a lot of success stories around these open source projects. So this is just, we know about 50 companies and organizations that are using Finagle right now, and this is just a few of those. But even though we do have all of these success stories about Twitter's Scala libraries outside of Twitter, there are some elements of our development process that make external adoption a little more challenging than we would like it to be. So one of these issues is our historically we've been slow to upgrade to new Java version or new Scala versions, and that's something that we're actively working on. Another issue is that since we don't, versioning isn't important for us internally because we have a monorepo. So we have only source dependencies between projects internally. And so, and one of the advantages of the monorepo is that it allows us to do sweeping refactors. So we introduce breaking changes a little bit more often than many Scala projects would, and those changes are not represented in the version numbers in a strict semantic versioning way. Again, this isn't for all Scala projects at Twitter, but for most of the ones that fit our core development process. Let's see. So another issue is that because SBT isn't our primary internal build system, occasionally people outside of Twitter will be the first to run into issues in our SBT builds. And again, this is something that we're working on. Okay, I don't want to go into a lot of detail about why we're still using Twitter's implementations of Future and Try, but I just wanted to highlight some of the directions that we're moving in this respect. So currently, there are enough semantic differences between our Future and the standard library's Future that it's not trivial, or even, we can't see a clear way to merging the two, although we'd like that to happen for the sake of both ourselves and the community. But there are things about our implementation that is very important to our use cases. So for now, we do supply and support converters. We're hoping to, so in the case of Future, there are important semantic differences, and in the case of Try, there really aren't. So we probably will adopt the standard libraries Try, and then eventually may adopt the standard library's future. Okay. So this is a statement by Oscar Boykin on the data platform team at Twitter about specifically why we don't use Scala Z. So our algebra library contains a lot of types that are similar to types and abstractions that are similar to abstractions in Scala Z. But we didn't use Scala Z from the beginning because our requirements make it difficult to depend on libraries like this that we don't actively maintain. So the things that we need from a library, like a foundational library for abstractions, are different from the things that most Scala Z users need. And so in general, we don't have many open source runtime dependencies from the Scala ecosystem. There are some efforts that are underway to change this a little bit. So Spire is a library for numerical computing in Scala that's very similar to Algebra also, and we're working with the Spire maintainers to attempt, as an experiment, possibly something that would happen down the line, to abstract out parts of Algebra and Spire into a library called Algebra that both of those would then depend on. We also have a new Finagle organization on GitHub that is a place where we brought a lot of projects from the Finagle community together with projects that we're using or have used in the past at Twitter that are related to Finagle. I want to leave a little bit of room for questions. So OpenZipkin is a community-driven fork of the Zipkin project that we may eventually be switched to internally. And then this last project, Finch, it's a new kind of experiment that we have. It's a library for building HTTP services on top of Finagle that we're using it as a demonstration of the value of combining Finagle with other libraries from the Scala ecosystem, like Shapeless and Argonaut. So we don't use Shapeless and Argonaut internally, but we've got this library that we also don't use internally, but that we are supporting, we are promoting the use of, that shows how Finagle can work together with libraries like this. And it's a very young project and it's very small, but we've seen a lot of activity around it over especially the last 6 months or so. So we know of at least 6 organizations that are using it in production, and we have a very large set for a young project of contributors, most of whom are not Twitter engineers. Okay, so in conclusion, I just wanted to highlight a few of the things that we're really excited about that are happening in the Scala community right now. So one of the things is, so because we've now merged our two internal monorepos into a single monorepo, we're expecting that it'll be much easier for us to make moves to new Scala versions more quickly. So that means that, for example, in Scala 2.12, which we're expecting will be released next January, there are facilities for interoperability with Java in both directions that we're really looking forward to. Also, so Abide is a project from TypeSafe that we're not currently using, but we're thinking could provide a very large value for our code base in terms of linting and making sure that programmatically the style and the abstractions that people are using fit our principles. And then Scala Meta is a kind of successor to the Scala macro system that is designed to also support large-scale refactoring tools. So we've worked on some large-scale refactoring tools for Scala internally, but we're hoping that we'll be able to merge that work cleanly with what's happening in Scala Meta. Okay, so before we go to questions, I just wanted to point out that Twitter is hiring Scala developers. So if you're interested in discussing roles and opportunities, please do stop by our booth sometime over the rest of the week. So any questions? Yes?
What is the typical list around Akka?
So there was some use of actors before Akka, or there was some use of Scala actors in the very, very early days of Scala at Twitter, but for various reasons, we've decided not to go that route. So the idea of futures is shared between Akka and Finagle, but Finagle is a different model to handling concurrency. Other questions? Is anyone who, yes?
So, do you have any libraries that are in the Monorail as well as outside? And if so, how do you manage like disconnection?
Right. So it's a good question. It's something that we're actively working on. So yes, Finagle is one of our open source libraries that it both lives on GitHub and we accept pull requests on GitHub. And those are synced to a directory in the monorepo. And the syncing happens. So we pull in patches, we merge them internally, and then we push out patches using just the Git patch. Yes, yes. We don't merge. We never press the merge button on GitHub specifically. We merge internally and then push the changes back out. So all of the metadata is maintained through that loop, but the actual commit is different when it gets back to GitHub.
But then internally, you then like when you cut an external release for the public release, like stable release, whatever.
Yes.
That is not reflected internally.
It's not reflected. I'm sorry.
It's not reflected internally in your usage because.
Right. Exactly. Yes. There are some cases where we do consume our own projects as external third-party dependencies, but that's not the standard story. Other questions? Yes?
Can you talk a little bit about testing in Monoreal? I mean, you said you refactor quite frequently.
Right.
You run tests and like, how do you manage this?
We run tests. We also have tools. So there's a tool called Diffie that we're planning to open source soon that allows us to do, to basically, so we test, so you make your change and then you run your test for the entire code base on our internal CI system. But then also we have systems like this project Diffie that allow us to capture production traffic and then run it through our services to make sure that a change hasn't changed anything significant about how a service operates. So using the monorepo both allows us to perform this testing across the code base, and we also have these other tools for making sure that the services are still speaking as we expect them to. Yes?
Sorry, I have another question. Do you anticipate a shift with the Scala usage and the Java usage with the coming improvements of Java 8 and Java 9 towards them, so that maybe balances out?
It'll be less painful to use both in the same code base. I don't know if there will be a large shift in the proportions. That's a question that we'll just have to see how it plays out. We're excited about it because it means that it will be it'll be syntactically and in terms of performance. Right. Okay, are we out of time? Let's see. We've got 2 more minutes, so one more question. Yes? I'm sorry? So we do Algebra, or Algebird is a project that lives outside of Twitter, but we do consume it as a third-party dependency, and it provides a monoid implementation. It provides a lot of those kinds of fundamental type classes and types. We do not currently use either Scala, Z, or Cats internally at Twitter. Yeah. Okay. Thanks, and please do either ping me on Twitter or stop by afterwards or stop by the booth either tomorrow or Friday if you have questions. Great, thank you.